Welcome back to Basic Electronics. Our next topic is RC coupled amplifier. First we will discuss a single stage RC coupled amplifier and its circuit explanation. So in this diagram represents a single stage RC coupled amplifier. In the previous class we have discussed voltage divider bias circuit. The same biasing circuit is used in this RC coupled single stage amplifier. Okay, what is an amplifier? An amplifier is a device which can amplify a signal, or a weak signal is amplified using an NPN transistor depending upon the amplification factor beta. So in this diagram, the name RC coupled amplifier means we have designed an amplifier with the help of NPN bipolar junction transistor and resistor capacitor combinations. Resistors and capacitors are coupled, so the name RC coupled amplifier. So in this diagram you can see the biasing voltage is VCC, input AC voltage is VI, R1 R2 are resistors used for voltage divider biasing, RC is the collector resistor, RE is the emitter resistor, CE is a capacitor which is connected parallel with the RE, CE is the bypass capacitor, Cin and Cc are coupling capacitors. Here we are applying input AC signal Vi through coupling capacitor Cin to the base of the transistor, and we are collecting the amplified output at the collector terminal or across the resistor RC through a coupling capacitor Cc. So we have discussed some configurations: common emitter, common base and common collector. In that three configurations, common emitter configuration gives good result. So we used common emitter configuration here also in RC coupled amplifier, where the emitter is grounded, or this emitter is common for base and collector. So the input AC Vi is applied between base and emitter. Output is taking between or taking across collector and emitter. So the emitter is common for input and output. So the common emitter configuration is used here. And also the biasing used is voltage divider biasing. Voltage divider biasing configuration is discussed in the previous class. This voltage divider biasing gives good stability, or it is the best biasing circuit. Then in the circuit, R1 R2 are resistors which forms voltage divider network. R1 R2 and emitter resistor RE provides biasing and stabilization in this circuit. What is the use of biasing? Biasing gives proper voltage to the NPN bipolar junction transistor, and it gives good output at the collector. it reduces the distortion and the efficiency will be high. So this R1, R2, RE provide good biasing and stabilization in this circuit. Then there are three capacitors, C in, CC. Both are coupling and cloaking capacitors. C in is the input coupling capacitor. It is used to couple the input AC signal Vi to the base of the transistor. C in is also known as blocking capacitor because it blocks DC signal. It allows only AC Vi to the base of the transistor. So the name blocking capacitor. Then CC is again, it is a coupling capacitor. It couples the output amplified AC output from the collector terminal to the output device, or it couples the amplified AC signal from the collector terminal to the input of the next stage amplifier. This coupling capacitor CC is also known as blocking capacitor because it blocks DC signal. Sometimes VCC will be present at the resistor RC. So VCC is a DC supply. If VCC is present across RC, capacitor CC will block that DC and it allows only amplified AC signal to the output. The next capacitor is CE, bypass capacitor. It is used to bypass the amplified AC signal at the emitter terminal. In the absence of CE, some voltage drop will be generated across resistor RE, and this voltage drop across RE will form a negative feedback and it will reduce the strength of the input signal, and thereby it affects the output and the gain of the circuit. So if CE is not present, AC degeneration will be happen in this circuit and the gain will be reduced. So the CE, the bypass capacitor, bypasses the amplified AC at the emitter terminal. So these are the basic circuit explanation. Next we can see the working of RC coupled amplifier. As I said, the amplifier is used to amplify a very small signal or a weak signal Vi, and you will get a amplified or a strong signal at the output side. So the input weak signal which is to be amplified is applied at the base terminal between the base and emitter. In the diagram, the input weak signal is Vi. Okay, in the previous module, while studying common emitter configuration, the current gain is equal to beta is equal to IC by IB, or IC is equal to beta IB, where beta is the amplification factor. So when the input weak signal is applied at the base current is multiplied with an amplification factor beta gives the collector current Vc. So this equation represents the amplification effect of this amplifier, and also there will be 180-degree phase shift between the input weak signal and the output amplified signal, or we will get an inverted output only. This diagram shows the input signal and the output signal. So the output signal and input signal both are not same. Output signal is amplified, also 180-degree phase shift is there, or it is the inverted output. The output is amplified, but why it is inverted? The answer is here. We know that while considering the output side of this RC coupled amplifier, we can apply KVL in the output loop. So we will get an equation like this: VCE is equal to VCC minus IC into RC plus RE if IC is equal to IE. So in the output loop, you can see the voltage is VCC. IC into RC is the voltage drop across RC. IE into RE is the voltage drop across RE, and VCE is the voltage between collector and emitter. So by taking KVL, VCE is equal to VCC minus IC into RC plus RE. This RE and RC are fixed. VCC is fixed. So the only thing we need to remember is the relation between VCE and AC. So while applying the input signal, that means when the input signal Vi increases, the base current also increases. So we know that the collector current is equal to beta into IV. So the collector current also increases. So from this equation, we can say that when IC increases, VC also increases. As VCC and RC plus RE are constant, when IC increases, VCE also increases, but in the negative direction or in the opposite direction. That is the reason of this inverted output. So VCC, RC and RE are constant. You can say that VCE is equal to minus IC. So remember this equation to understand the relation between the inverted output and the input. So in this class we have discussed the basic explanation about the RC coupled amplifier, a single stage RC coupled amplifier. Its working based on the equation IC is equal to beta into IB, and the relation between input and output. The output is amplified, but 180-degree phase shift is there because of this equation. When IC increases, VCE or the collector voltage increases in the opposite direction. So this is a single stage amplifier. In this diagram we can see a two-stage amplifier, or it is a cascaded amplifier. So the name cascaded means one more stage is attached to the single stage. In this diagram, CC1 is the output coupling capacitor which couples the output at the collector terminal of the first stage to the input of the second stage. Here also NPN BJT in common emitter configuration is used. VCC is the biasing voltage, R1 R2 RE provides biasing and stabilization. Coupling capacitors are used here also. The function is same. These are the coupling and blocking capacitors. As we know, a single stage RC coupled amplifier gives 180-degree phase shift. In this two-stage RC coupled amplifier, the total phase shift will be 180 plus 180 is equal to 360 or 0. So the input and output are in phase, or there will be no phase difference. The output is collected at the collector terminal of the second stage, or the collector terminal of the second BJT. So this is the practical case. We can attach so many stages like this. Only thing we need to remember is the output of the last stage is supplied through a coupling capacitor to the next stage. The frequency response of this RC coupled amplifier will be discussed in the next class. Thank you.